Alright guys, let's look at another example here. This is a question, a past question from JAMP. An object is projected with a velocity of 80 meters per second at an angle of 30 degrees to the horizontal. The maximum height reached is, so we're to take g, acceleration to gravity, as 10 meters per second squared. An object is projected with a velocity of 80 meters per second at an angle of 30 degrees to the horizontal. The maximum height reached is what? So this is a diagram for the question. It's projected with an initial velocity of 80 meters per second. So vertically, the vertical component for that is 80 sine 30, while the horizontal component is 80 cos 30 degrees. Okay, so this is the maximum height that the object scales. Okay, so we are told to find the maximum height. So it's a vertical distance. Since we are not given, okay, so we look for the equation of motion, either the first, second, or third equation of motion. We have to choose which of them that we can use to solve for the vertical height h. Okay, so since we are not given time in this expression, in the question, there's no time, so the second equation of motion will not apply. The first equation of motion will not really help because both first and second have a time t. So let's test the third equation of motion, which is v squared is equal to u squared plus 2as. So since at maximum height, you know that at maximum height, the vertical velocity becomes 0 because the vertical component of the velocity becomes 0 because of gravity slowing it down. So at this point here, we have the vertical velocity becomes 0, a momentary stop. So vy is equal to 0, acceleration is minus g. So we are choosing the third equation of motion to solve to get the vertical height. So our s, the s in this expression is distance, so we can replace our vertical maximum height, provided that we have our final velocity vy is going to be 0 because at this point here, the initial vertical component of velocity is now the initial. Of course, this is initial. The final up here at this point is 0. Our acceleration will take it as minus g, and we're giving g as 10. It's minus g because it's acting downwards. Okay, so it's slowing down the object. Okay, so we have slot that into the third equation of motion. Our final velocity is 0. Take note, we are calculating at this point, so v squared is 0 squared. So putting initial component, this is the vertical component uy, so we are using 80 sine 30 degrees. Basically, so we have that, so 80 sine theta, 80 sine 30 degrees all squared because we have u squared. Okay, so square that expression all squared, minus 210, this is gravity, and it's negative because it's acting downwards, it's slowing down, this is negative acceleration. So our distance s is replaced with height, with h, which we are looking for. So I'm going to make this height h the subject of the formula. So this comes over here, becomes positive 2 times 10h. So if you square all of this, because the expression says square, if you square 80 squared becomes 6004. You square sine 30, sine 30 is half, so half times half is 1 over 4. All over here, so we're dividing both sides by 2 times 10, so that h stands alone. So the maximum height is, point that into calculator, I get to be 80 meters. So our maximum height is 80 meters.